Hey there, geometry. This is going to be the second video of the vocabulary for circles. We're going to, similar format here. You're going to watch the video as we're going along. You can fill in on that vocabulary organizer, and then, like I said, I'm going to print those out for you so you can sketch the diagrams when you get to class. Okay, so right now we're just focused on filling in the word parts of the definition, and then we'll go through the diagrams later on. Okay, so pause the video, use the internet. I'll actually show you a link that'll help you with a couple of these because they're not always found in perfect glossaries the way that I want you to define them. So bear with me here, and we'll pick up with now the angles involved in a circle. So we're picking up here with arcs. You should have all this filled in from the last video. So now we're on the second page talking about arcs. All right, and we're going to go back to our diagram here, but now what you'll see is that I drew two radii. Okay, so radius is the singular, radii is the plural, but they meet at the center here. And this is going to be a crucial fact when we talk about the angles, but for right now I want to talk about this piece. An arc is the part of the circle that is formed by the endpoints of the radii. Okay? It is the part of a circle formed by the endpoints of the radii. So if you need to see that, make sure you Google it and check it out. There are really two types of arcs that if we get into detail we would talk about. A minor arc is like this little piece. It's less than half of a circle. Okay? And then a major arc, which is this big piece, which would be more than half of a circle. And we'll spend a lot of time later on talking about arcs and how we measure them and all that kind of stuff. But they're both arcs, minor, less than half, major, more than half. But again, they're the part of the circle that connects the endpoints of the radii. Okay? And in this case, what you see here is what we call an intercepted arc. So if you're flipping back over here, this is all really going on arcs. They're intercepted by the angles that we form, and we'll talk through that. Circumference is going to be the distance all the way around a circle. Okay? It's a lot like perimeter in a polygon. We just give it a special name now that it's in a circle. It's the distance all the way around. So if I were to get rid of my radii here and just look all the way around, if I were to be able to measure this, and we will do some practice measuring these and finding circumferences, that's what we mean by that. But really what I want to focus on in this video are these angles. So you see a central angle, an interior angle, an inscribed angle, and an exterior angle. And the key to these is understanding where the vertex of the angle lies. Remember, vertex is where those two lines or line segments connect. This particular angle that I already have drawn is called a central angle because the vertex is at the center. So if I'm on my vocab, a central angle is any angle whose vertex is the center of the circle. So when two radii connect, those are called central angles. Now what I want to stress is I can extend these, say I make that a diameter. This is still a central angle. It doesn't have to be two radii. It can be a diameter and a radius. They still form a central angle here and a central angle here because the vertex of those angles is the center. Same thing is going to be true if I draw this as a diameter. Okay? I have now four central angles. One right here, one right here, one right here, and one right here. But all of them cross or have that vertex right at the center, central angle. As we move to the interior, now we're going to say that this is an angle whose vertex is inside the circle. So any angle whose vertex is inside. And all that's going to do is have me shift this from being a diameter to a chord, or in this case, we'll make it a secant. This vertex still forms four angles, here, 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 and here. But now it's on the interior of the circle. It's no longer at the center. Okay. If I make that secant, okay, I've drawn an interior angle. If I rotate this around, and I'll stretch that out, I still have interior angles. As long as the vertex is somewhere inside of the circle, it can get real close to it. Okay? Even right there, that vertex is still inside of the circle. What happens if I continue to move this secant segment, though, is I can make that vertex happen right on the circle. And I will highlight that a little bit more by kind of shrinking these so that they just touch right at the edge there. When that vertex is on the circle, that is what we call an inscribed angle. Okay, now generally what we'll do is we'll see it as chords, not secants, but it could be a secant. But that vertex is on the circle. Okay, so an inscribed angle is any angle whose vertex is on the circle. So we started on the center, went inside the circle, now we're on the circle. Okay, I can swing that around and put that anywhere I want. I can make it, I thought I was going to get a diameter there. I can make it a diameter and a radius. I can make it 2 chords, I can make it 2 secants. As long as the vertex, as long as the line segments or lines are crossing on the circle, then that will be an inscribed angle. And then lastly, we have this exterior angle, and all that's going to do is take these segments, and it's going to have them cross each other outside of the circle. So here we have 2 secants that cross outside of the circle. I could have a secant and another secant that goes through the center, it'd be like a diameter but extended, okay? And that vertex is still here outside of the circle. I can even make this into a tangent line and do something like this. That would also be an external or exterior angle. Okay, so an exterior angle, any angle whose vertex is outside of the circle. That would look like this. And what we'll see is how we measure those, how we deal with all of the arcs that are formed, that sort of thing. Okay, but I want you to make sure you have those filled in. So you've got arc, part of a circle, circumference, the distance all the way around the circle, central angle, an angle whose vertex is on the center, interior angle, an angle whose vertex is inside of the circle, an inscribed angle, any angle whose vertex is on the circle, and an exterior angle, any angle whose vertex is outside of the circle. Again, we'll print these out, we'll draw the diagrams, and we'll go from there. Thanks for watching. Have a great day.